Today's lesson is on finding the surface area of prisms. So in section 12-2, all students will be able to find surface areas of prisms. Let's start off with a mathematical definition of a prism. A prism is a three-dimensional object or three-dimensional figure in which there are two bases that are congruent and the other sides, there could be more than two. There will be more than two. The other sides, we call those faces, are rectangles. So a prism is a three-dimensional figure in which there are two bases that are congruent and the other sides or faces are rectangles. So let me include a picture here of what we call a rectangular prism. This is a rectangular prism. It's called a rectangular prism because the two bases are in the shape of rectangles. So if I take these opposite sides here, let's say this side here and this side here, those are the bases of our rectangular prism, and they are congruent to each other. They're the same exact size and same exact shape. And our goal is we want to find the surface area of that prism. That is, if I were to paint this prism, how much surface area would I use if I wanted to paint all six faces? So there's a face on top, a face on the bottom, so there's my two bases, so that's two. A third one in front, right there. A fourth one on the side. A fifth one in the back. And the sixth one is there on the left. The idea of finding the surface area of this prism is based upon what we call the net of the prism. So this is the net of that prism. If we were to unfold these sides into one big flat shape, this is what it would look like. And we can see here everything that's in blue, these two blue ones, that's what would be in the front and the back. The red is the top and bottom, and the green is the left and right. So we've unfolded that. And the idea is we want to find the areas of these six rectangles. We'll talk about how to do that in a moment, but the next thing I want to talk about is another type of prism called the triangular prism. Here's an example of a triangular prism. It's called a triangular prism because the two bases are triangles and they're congruent. This triangle right here and this triangle right here. Notice that in both types of these prisms, the rectangular prism and this triangular prism, notice that those two bases are opposite each other. They're opposite and parallel. So bases of a prism are parallel and congruent. And if we look at this triangular prism, we can see that there are 5 faces in total. We have the two triangles. There's the two triangles. And then there's a rectangle here on the bottom. There's a rectangle here on the right side. And there's another rectangle here on the left side. So there are the two bases, the two triangular bases, and the 3 rectangles. Here we have the net of our triangular prism. If I start off with this triangular prism, if we were to unfold these sides, here is my two triangular bases, and then the three rectangular faces. Those ones right there. Notice that in the triangular prism, it does just anything that's called a base, the base does not have to be on the bottom. For example, in this triangular prism right here, notice the two triangles are in the front and back. For this triangular prism, the two triangles are on the top and bottom. So what we want to do, again, is we want to find the surface area of those prisms. What we want to do is if I were to paint all those surfaces, how much area, how much space would it take up? We're not talking about volume, okay? We'll do volume another day, but for now we're doing the surface area. Is it going to be a two-dimensional area that we are finding? So to find our surface area of any prism, to find the total surface area of any prism, find the area of each face and add them up. Okay, so let's do a few examples of that. Let's go to our notes page here, notes 12-2, and let's start off with problem number 1. We have a rectangular prism, and we want to find the total surface area. So one thing you want to keep in mind is that if I have a rectangular prism, we always end up with 6 rectangles. There's always 6 rectangles that form the rectangular prism, and we can see them here in this net. For a triangular prism, we're going to have 2 triangles and 3 rectangles. And again, you can see them visualized here in this net, the 2 triangles and the 3 rectangles. So this is how I want you to show you work on how to find that total surface area. Let's start off with this rectangle and this rectangle. The dimensions of those 2 rectangles are 5 meters by 12 meters. So this is the one that's on the right side. This is the one that's on the left side. I think the easiest thing to do here is let's draw those 2 rectangles and label their dimensions. I want to do that in red just to show you that's the work you need to show. So that dimension, that's 5 meters by 12 meters. And then I have another rectangle that is 5 meters by 12 meters. Now to find the areas of those rectangles, we know the area of a rectangle is base times height. So for this problem, we're doing 5 times 12. So the area of that rectangle is 60, and the opposite rectangle is also 5 times 12, which is 60. So that is this rectangle and this rectangle. Let's do the same thing with the rectangles in the front, this one here, and the back, this one here. Again, you can see that the dimensions are 5 by 12. This 5 here refers to this height between the 2 bases, and that's going to be the same all the way around. So this rectangle here is also 5 by 12, and this one here will be 5 times 12. You don't have to write out that formula every single time, maybe just for the first one. I'm okay with you just saying now, area is 5 times 12, so that's 60 for this one, and 5 times 12 is 60 for that one. So far we found the areas of 1, 2, 3, 4 rectangles. Now what we want to do is get the other 2. In this case, the top and the bottom. So those are squares with dimensions 12 by 12. So area of a square is s squared. So we'll do 12 squared is 144. And then for this one, 12 squared, 12 times 12 is 144. Now, to get my surface area, we're going to take the sum of all 6 areas of those 6 rectangles. So my surface area is going to be 60 plus 60 plus 60 plus 60 plus 144 plus 144. And when we type that all into your calculator, it comes out to be 528. Now, be careful. Remember, we're talking about a surface area. We're talking about an area that's two-dimensional. So my units are going to be meters squared. So the final answer for problem number 1 is 528 meters squared. Next, let's jump down to problem number 3. I want you to try problem number 3 on your own. What you're going to do is find the areas of each of those 6 rectangles: front, back, left, right, top, and bottom. And what I want you to do is show your work the same way I did. I should see pictures of those 6 rectangles, show the work on how you found those areas, and then show the work on how you got the surface area. So what I want you to do is press pause right now, try the problem on your own, and then when you're done, unpause it and you'll see the work that I've set up. So go ahead and pause it right now and then try it on your own and then unpause it. Okay, here's my work and answer for problem number 3. I drew pictures of my 6 rectangles and found the areas of each of them. I got 66, 66, 72, 72, 132, and 132. And then I added them all up to get 540 square feet. The 6 by 11 rectangles, those ones, here's the 6, here's the 11. So we're talking about the front and back rectangles. The 6 by 12 are this one right here, 6 by 12. That's the right side and the left side. And the 12 by 11 rectangles are the top and the bottom. Let's move on down to problem number 5. Now we have a triangular prism. The 2 bases, there's one triangle and there's the other one. Then I have 3 rectangles. This one in the front, this one on the left, and this one on the right. We're going to approach finding the surface area of this prism the same exact way. You're going to draw your 2 triangles, and what I want you to notice in this figure is when you look at like this bottom one, notice they put a right angle symbol there. So that tells me that we have a right triangle. So I'm going to draw a right triangle. I'll put the right angle symbol. One leg is 6, another leg is 8, and the hypotenuse is 10. So 6, 8, and 10. The area of that triangle is 1/2 times 6 times 8. 1/2 base times height. One half times 6 times 8 is 24. So 24 square feet is the area of, let's say, this bottom rectangle. The top rectangle is going to have the same exact dimensions because they are congruent. And it will also therefore have the same exact surface area. Sorry, the same exact area. 1/2 times 6 times 8, which is 24. Now let's do our 3 rectangles. Let's start off with the one in front here. It has dimensions 3 by 10. So its area is going to be 3 times 10, which is 30. Now let's do the one on the right side. That one is 3 by 8. So that area is 3 times 8, which is 24. Then the one on the left over here is going to be 3 by 6. So that area is going to be 3 times 6, which is 18. So now to get my total surface area, I'm going to take these 5 areas that I found and add them up. 24 plus 24 plus 30 plus 24 plus 18. That adds up to be 120 square feet. Now, on your own, try number 7. Let's do it the same way. Work through it on your own. So press pause, work through it on your own, then unpause it and compare your work to mine. Draw your 2 triangles, draw your 3 rectangles, find the areas of each, and then add them up. So here's my work for problem number 7. We have our 2 triangles. The one on the left here is 3 meters by 4 meters by 5 meters. I know that this distance is 4 because it has to be the same as that 4. Remember, they're on rectangles, those opposite sides are congruent. So 3, 4, and 5. So the area of that is going to be 1/2 this base times this height. I know I'm going to use that for the base and height since they're perpendicular to each other. This triangle is the one in the back. It has the same dimensions, so its area is also going to be 6. This rectangle, this 4 by 10, is this top rectangle right here. This dimension is 4, and that dimension is 10. That's the top one that has an area of 40. This 5 by 10 rectangle right here, that's the slanted one in front. This distance is 5, this distance is 10. And then for the 3 by 10 rectangle, that's the one in the back here, 3 by 10. It's that rectangle right there. When you add up all 5 areas of all 5 rectangles, we get 132 square meters. Now what I want you to do on your own is work through the even problems. Number 2, number 4, number 6, and number 8. But before you do that, I do want to point out one thing. If you look at like the 2 triangles that we did, problems 5 and 7, you'll notice that they are right triangles, but not all triangles are right triangles. If you take a look at problem number 6, you'll notice that the triangles are not right triangles. We don't know, they didn't tell us anything about this angle being a right angle, but we have a perpendicular here to show us that the height of this triangle is 2.7 to this base of 10. So when you do a problem like number 6, the triangles you're drawing is going to look like this. That distance is 10 and the height is 2.7. So the area of that triangle is going to be 1/2 times 10 times 2.7. So right now on your own, try those even problems. Check your answers at the end. And that is the last part of me explaining this lesson on finding the surface area of prisms. And I just realized I spelled prisms wrong. Hopefully you made it all the way to the end and caught that. There we go. Prisms. Okay, thank you.